Okay, my students, here's our lesson today. Just two little permutations. A permutation is where you're just changing the order of stuff, and the order matters. So it's just a fundamental counting theorem, essentially. But we're going to focus on that tomorrow and Wednesday. So if I said, how many ways could you put Sue? Well, you could go S-U-E, S-E-U. What the mercy? You could go U-S-E, U-E-S, and then E-U-S, and then E-S-U. Now, it used to be a game, what mercy, that we would play where how many different words could you make from a word? So this one, you got Sue and you got use. But there's 6 ways. So you have 3 different letters. How many ways could you arrange it in a row? It's just 3 factorial. 3 times 2 times 1. Now the trouble with this one is we don't have different letters. We do not have different letters. So since we don't have different letters, we have to eliminate the repetition. So, for example, if I said, okay, one way is B-O-B-B-Y, I could switch this B with this B. It's not a change because it's still B-O-B-B-Y, Bobby. So how you do that is you do the factorial of all the letters. 1, 2, 3, 4, 5 are all the items. Then you have to get rid of the repetition. So each letter that repeats, or item if it's not letters. So 1, 2, 3 B's, you divide by 3 factorial. Because that's what repeats. So on a calculator, now for Desmos, you have to go down like we did with trigonometry in the bottom, and there's a section that has it. For a regular calculator, most of them have it. Now, I'm not going to go through all the way to do a factorial because every calculator is different. So this one has a PRB, but oh my goodness. There it is. So 5 factorial is 120. Divided by 3 factorial, I know, is 6. So that means that goes from 120 ways to 20 ways. Now, Mississippi, holy cheese. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factorial. Now, if it was just 11 factorial, you would have 3991660. Holy tree. 39 million ways. A little bit more. But this SSSS, the I's, the P, cancel out. So I gotta, there's 4 S's. There's 4 I's. And there's, let's see, did I miss anything? How about 2 P's? By the way, just as a question that might be on a test, is 2 factorial times 4 factorial the same as 6 factorial? Oh, excuse me, 8 factorial? No, because 2 factorial is 2, 4 factorial is 4 times 3 is 12 times 2 is 24. So that would be 48. 8 factorial is 8 times 7 times 6 times 5 times... Oh my goodness. So anyways, so we have 11 factorial divided by 4 factorial. I could just do 24, couldn't I? It'd make my life so much easier. and I get 34650. So we go from 39,916,600 to 34,650 once you get rid of all the repetition. Now, right now, try Jesus loves. See if you can do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by, there's, let's see, 2 E's. 1, 2, 3 S's. Is that it? The E's. S. I think that is it. U, L, yep. So 3 factorial is 6 times 2 is 12. So 10 factorial. La 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 la. Divided by 12. And I get 302,400. Now, what about items in a circle? If I have 3 people standing in a row, how many ways can they do it? Well, notice when, let's say I have Bob, Sue, Jim. So when Jim moves, order changes because he comes over here. But what if I have them in a circle? If they rotate, notice they're still in the same order. Jim, Bob, Sue. Jim, Bob, Sue. So what happens is when you put things in a circle, you actually knock off one of the choices before you take the factorial. So in a row, this is 3 factorial because when they move, it goes on the other side. It actually changes the order. But in a circle, it doesn't change when one person moves. So you just subtract one of the items before you take the factorial. So 4 people in a row is actually 3 factorial. So 3 times 2 is 6 ways, where if they were standing in a line, it'd be 4 times 3 is 12 times 2 is 24. 5 people in a circle would be 5 minus 1 is 4 factorial. 4 times 3 is 12 times 2 is 24, where if it was 5 factorial, it'd be 120. So in a circle, it's n minus 1 factorial, with n being the number of items. So, what would 6 people in a circle be? That's right. 6 minus 1 factorial is 5 factorial, which is 120. Okay, here's what I want you to do. Do not send this to me. So it's practice by tomorrow, and then I'll do it at the start of the video tomorrow. But find out how many ways could we write Jimmy, different ways. That's the key. Jimmy, 10,700. Wow, Mom. And JoJo is a hobo. And how many different ways could you put 7 people sit at a round table? And how many different ways could 10 people stand around a circle? Okay, that's due tomorrow at the start of class. But again, it's practice. Don't send it to me. Have a good day.